Hello YouTube, De-bodgery here, aka Richard Gumfaw on Facebook. Welcome to EV Components Review. If you like my content, please subscribe, comment, give me a thumbs up, hit the bell icon, all that stuff. Anyway, all that stuff helps my channel grow. You are looking at the stator for a QS165 IPM inrunner. There are things about this that I don't like, and there's things about it that I do like. Anyway, let's get into it. This is going to be a two-parter, and later on there'll be another video where I do things like measure phase-to-phase resistance and inductance. Once the motor is back together again, I will also do back EMF testing. So there's going to be several things that you'll get to see in here as we go along. This video is just going to cover the stator and not the armature and the shell pieces, anything like that. Okay, so first thing is, this is the sine coast version, not the Hall version, and it's got two connectors on it. So this is looks like JST 1.0 to me, and this is JST 2.5, which is a very inexpensive but very reliable connector. And this is the Hall cable, or I'm sorry, the temperature cable. And rather than using another JST connector, they just soldered it in place. I don't get that one. Yeah, they should have put that on a connector. They did put silicone over top of this so they'd all come in place and stay put. And you can see the silicone on here too. I've mostly cleared most of that away so you can get to the connector. But that was also true on here as well. So yeah, you can see the silicone on there. So it was secured in place relatively well. Cutting corners like this, and then you've got a second connector for all of those same sine and cosine signals right here. Over there, just do that one too. Why did you do that? Yeah, they shouldn't have soldered the wires in. They should put it on a connector, for the temp sensor. Anyway, at least there are Teflon wires, so that's good. Anyway, let's move on to the other thing. So here is obviously your three phases, and they are ring terminals, and the wires themselves inside are soldered in. They're crimped and soldered. So this is how I do this kind of thing too. So I definitely like to see crimped and soldered, and that's very good. I don't like the insulation and the heat shrink on here. This wasn't done particularly well. For example, you can see that the end of the cable can rub against these strands down here, and there's no heat shrink down there. Well, fat lot of good that's going to do. This is going to move like this, and it's going to wear through the insulation of this wire here against those wires there and create a stator short. You don't want that. So yeah, this is not good. The heat shrink should have gone all the way down inside there, and then there should have been silicone put around that stuff to secure that stuff so that it can't move against each other, and that's not here. And that's true for all three phases. You can see it here as well. It all can move against each other. That's just asking for, slow rubbing like this, and it's going to break through the insulation. Exactly how long that's going to be before that happens, I can't really say for sure. I just know that's going to happen because it's happened to me for this very reason. You can also see that, none of this stuff is secured very well, so all of this binding thread is massively insufficient. So yeah, I'm going to take all this stuff off before I use this motor for anything, and then I'm going to rebind it with new motor winding thread, and then after that I'm going to coat everything in shellac so that it can't move. And before I do all that stuff, I'm going to pull all this heat shrink off of here and shove it all the way down inside there so that that can't even touch, and then put silicone down in there so that they are bound together. So yeah, I'm going to do several fixes on this motor before this thing ever sees the light of day, because this is not very good. And all this stuff, this is definitely not any good. Yeah, that's a problem waiting to happen. In several places there are loose strands, like right there, for example. I can stick my spooger right underneath that one. That's not cool. And there's another one. Right here. There's another one. Just sitting there, flying blowing around the breeze. Over here, there is several right there. I'll turn it the other direction. Yeah, so all this stuff is got multiple loops in it. Yeah, you should not do that. That's called shoddy work. So QS, you should have done a better job. I've heard a lot of good things about your motors. I've used your motors in the past, like hubs and things. So yeah, the fact that there is things like loose strands and none of this stuff is bound together very well, come on, really? That's not cool. Probably the best thing I can say about this side of the motor is that the ring terminals are crimped and soldered. But yeah, all this loose stuff in here, that's not okay. That's just asking for a stator short. This right here, Underneath there is the starts of all three winds where they come together. And so that's your Y connection inside the motor. Obviously, this motor is wired for Y. So yeah, that's all inside. That part is all pretty solid. This part is all bound up nicely. So I guess I do have a couple good things here. That part's not going anywhere. That part's pretty solid. But other places in here, meh. You'll notice I'm doing this on my ESD mat. So this is kind of a hard rubbery surface. It's not going to harm the motor windings. I would not do this on, like, say, a hard table or like on a concrete floor or something. If I did, I'd put it, like, say, on bubble wraps just to protect the windings from scuffing and bruising. But on here, this surface is plenty soft for this. All right, on the other side, this is a little bit better. And they do have shellac in here. So, like, none of these windings move very easily. But at the same time, you know, like right here, you can see there's a loop right there. I can stick my spooger underneath it, and there's several loops throughout here. So it's super cool that you've got some shellac on here to bind all this stuff together, but there's still no winding thread, and they should have done that. And yeah, the shellac isn't really doing its job all that well. So, like, yeah, here's another loop. I've got my spooger under. I don't want to pull on them too hard, but yeah, there's you know, loose strands like this throughout here. I thought QS was a better company than this, to be honest. But yeah, there's a lot of things that are kind of meh. You can see one of them, wherever it is. Yeah, right there. You see a loop. Yeah, there's that kind of stuff in here. It's like, come on, guys, you can do better than that. Or how about, like, right here? Let me turn that around. Yeah, you can see all of that right there. It's all just loops. Yeah, you see all those loops right there. Yeah, pull all your strands together all at the same time so you don't have looping strands. And this is hand wound, I believe. It sure looks hand wound to me. I don't think this is machine wound. So yeah, the person that was doing this just simply went too fast. And yeah, if they would have, they wouldn't have this kind of thing, because they would have been paying attention to what they're doing, and they would have made sure that all of their strands would have been pulled snug, and that's not the case. It looks to me like this is probably 5 turns per stator tooth, rather. I've already measured this. This is 35 millimeters across right here. You know, according to QS165, 35H, that's what this is, right across the face of the stator teeth and the magna heights. It's 35 millimeters. So that's that. The 165, I don't know what that number means. I can tell you this distance in here, at least on the armature, is 114 millimeters. So this is probably like 116 millimeters. So 165, I don't know what that means. Anyway, yes, there's some quality issues with the windings that QS ought to address. Not super fond of this. This outer heatsink is probably going to do a decent job. Don't really have a problem with that. Let's move on to the armature. So the armature is reasonably good in some regards. In some ways, not so much. You can see this blue epoxy on here. This is basically balancing epoxy. You spin the armature up, you know, probably way over what its spec RPM is, and you're looking for vibration, and you have a special piece of balancing machinery that does that. And then you spin it down, and it tells you where your light spots are, and you stick down a little blob of epoxy. You just use your thumb and go, pfft, that's it. Anyway, so that's what all these are, and you can see a bunch more on this side as well. So I'm glad they did this, because, you know, the motor armature definitely needs to spin and not vibrate and be out of balance. So this is all good. Yeah, the epoxy stuff, as long as it sticks down and stays down for life, then I don't really care that they're using that. It's a commonly found method in lots of motors that they're balanced with epoxy like this. The bearings themselves, these are Chinese, I'm going to guess. So yeah, you can kind of see it on there a little bit. Yeah, so right there, it says C and U on the bearing, and right there is the part number for it, and that says 6005 RZ. So yeah, that's pretty much the bearings. They are not very precise, so like if I do this, I can feel some wiggly in there. So the bearing race and the bearing balls are not really good and precise, and the same thing for this bearing. So this one again is another C&U bearing, and you can see it's a 6202 RZ. I like that they're sealed, so that's good. But yeah, there's that C&U logo. Don't know who that brand is. China in Union? I'll have to look it up. I don't know. But same thing with this one. You know, if I wobble it side to side, I can feel a little bit of play in there. It's not quite as much as the other bearing, but yeah, they're not really precise bearings. This little nut right here, there is a magnet inside here, and this is your position sensor. So it's got a pole here and a pole here on this little magnet, and I'm guessing it must thread onto the end of this shaft, is how that works. It's not centered either. It probably doesn't show up in camera, but the nut is not centered on the shaft, so it's gonna kind of like lobe, which is bizarre. But yeah. Anyway, quality is not quite as good as I'd like. You can see on this aluminum cap, there's a gap underneath there. And these caps basically retain the magnets inside the armature iron. How those are held in place is, you can kind of see it down inside here. Yeah, so right down inside here, there's a shoulder, and that's part of the shaft. It's all machined as one piece. So basically, you press the shaft down onto the armature stack, and then it just bottoms out. And it bottoms out on this aluminum piece right here. And that's pretty much, as far as I can tell, that's holding this aluminum in place. There is a keyway right here. You can kind of see that on camera. Yeah, you can see it in there. But I don't see that the aluminum goes through there. Yeah, and besides which, this is a wider shoulder in here. So I don't think that keyway retains this aluminum plate. So something else has to retain it if it's actually retained by anything. Otherwise, this could slowly migrate around, in which case all of this balancing stuff could also move. However, there are also some little rivets that hold this whole entire stack together. And so these holes are through those. So probably this plate really can't migrate just because it's all compressed together and sitting over top of those rivets. The other side, again, you can see the same thing. There's the other end of those rivets in those holes, and this side is just the same thing. It's, you know, it's got a decent sized gap underneath it, but they're basically just retaining the magnets in there. But you can see me move it. Yeah, not super fond of that. And this end here, so you can see this keyway right there in the shaft. So all of this stator iron has little protrusions that fit into that keyway, and that's what keeps the shaft from turning separate from the armature iron. Anyway, all that stuff is just sandwiched together by this right here, which is just a press fit ring. It's, you know, it's just basically forced down over top of the shaft to squeeze all the stuff together, but that's it. There's no circlip on here or anything like that. Anyway, yeah, this nut right here. So I don't know what that thread is, but you know, it's just righty-tighty, lefty-loosey. I did have to use an impact driver to break that loose to get it off. And here is the pulley that was on there. Yeah, you can see that the key in the keyway does not extend the full length. And here's the keyway here. So this is like 75%, 65% full, something like that, with key. So that's basically, you know, stressing this more than it needs to be. I will be replacing that key with one that actually fills the whole entire keyway, because I don't get that. Yeah, that's attention to detail, and they didn't do it. Anyway, the armature is okay-ish. I've seen worse. I've seen better. Get off of there. But yeah, it's okay-ish, and it's obviously at least had attention given to it to balance it out. So I think that's it for this video. In the second video, I will talk about the shell pieces, screws, stuff like that.